So that's 40. So I'm an active member of the French community, and I'm also the main developer of an extension called PostgreSQL Anonymizer. So my journey, basically I've been working with Postgres for the last 25 years, and I just discovered Rust last year, so probably most of you know much more about Rust than me. So anyway, I'm going to try to keep up. So my story is like a few years ago I started this extension, and I had to write a lot of C code, and I really don't like to write C code. And so last year I decided to rewrite everything in Rust, and so that's my story. So I'm going to talk to you first of all with what is a Postgres extension, so you understand what is at stake here. And then I will present a REST framework called PGRX. And then we'll give you just practical examples so you see really quickly how to get involved, and share the lesson that I learned when I did the migration. Okay, so let's start with one of the worst advice in computing is choose the right tool for the job. So this is really dumb, and with Postgres especially, because you will always find people saying, okay, you need the specific database for this kind of data, maybe MongoDB for NoSQL data or whatever. This is utterly false. PostgreSQL is good enough for almost all kinds of usage. And why is that? It's because PostgreSQL is not a database, it's a platform. You have hundreds and hundreds of extensions that will handle almost any kind of use case you have. So it may not be the best in all of these areas, but it's good enough. And most of the time, good enough is better than choosing the right tool for the right job. So this is a bit of an explanation. But so why is Postgres good enough in all these areas? Well, it's because of its unique ecosystem of extension. So we do now have around 1,000 known extensions published on GitHub. Of course, they are not all ready for production. I would say you have one quarter of them that are okay to run in production, but that's already very impressive. You know other database system has this kind of ecosystem around it. So what's a Postgres extension? Well, it's quite simple. It's basically SQL objects and some procedural code, or a compiled library, or both. So the easiest way to write an extension is to write it in SQL or in PL code. It's easy. It's a great way to move code to share functions between your databases. It's very stable between major versions. It's kind of slow, but you can write it in kind of any type of language you want. So the most common language is PL PGSQL, which is inspired by the Oracle PL SQL language. But you also have all kinds of flavors of language are possible. So basically, here's an example of a function you can write, and yeah, this one is written in SQL, but you could write, again, you can write in any flavor you want, and then you can call it within your select queries. Yeah, you might have seen that there's a PL Rust. It's great. I'm not going to talk about it today because it's a whole other story. But yes, you can run Rust at the procedural level. But I'm going to go deeper because what I want with my extension is go directly into the core of Postgres. And so yeah, generally the way to do this is to write the extension in C. And so this extension will be, it's a library that will be loaded when the instance starts. It's really fast, it's direct, and you have that direct access to the internals. So you are inside the database engine. And you can call any kind of PostgreSQL function inside this. So it's very low-level code. You have no abstraction. Probably every year, where there's a new version of Postgres which is released, your code will break because they will add new signatures to function or new features. And so you'll need every year to maintain your extensions to keep up. And all the tooling around it, which is called PGXS, is very, very limited, actually. And also, you have no security barriers, so you get a lot of seg faults. And if you seg fault an extension, the entire instance will crash. So let me repeat that. If your extension crashes, the whole server will crash too. So it's kind of bad. Yeah, people really don't want that, actually. If they install your extension, they don't expect that your extension will sink the whole ship if it has a problem. So can we have the best of both worlds, actually? Can we have the safety of the PL function, but also the performances? We want high-level abstraction, but we also want to have access to the Postgres internals. And we want a modern language, but we also want stability. So this is what PGRX is for. It's a breath of fresh air, actually. If you're an extension developer, it's a really nice solution. So the idea is a framework that bridges the gap between your Rust code and the PostgreSQL internals. And you can write Rust extension without it. It's possible. You don't need it, but actually it really makes your life really easier. So the principle is just you're going to expose Rust functions inside Postgres. And you will have a direct mapping between the PostgreSQL data types and the Rust types, and the other way around too. So basically, if you have a text, it's going to be interpreted as string or str in your code. If you have an integer, it's going to be an I32, etc., etc. And for the types that don't exist in the Rust directly, like date, the PGRX framework will provide you those types. And of course, null does not really exist in Rust, so you will have an option none for that. Development feedback loop, so it's very easy to try something, get feedback, and move on. All right, so, but what is PGRX? Because if you're going to work with this to build your extension, you need, like the previous talk was saying, if you add this kind of dependency to your project, you better have trust in this project. So this was a project that was launched by a single company, but is now transferred to a foundation. So there's a whole collective around it, so it's trustable. And it's also, there's also a really friendly Discord community around it, and which is very helpful when you want to start. Okay, that was for the big picture. Let's go in practical details now. Okay, let's go. So first of all, we need to install that PGRX with classic cargo tooling. And we're going to initialize the development environment with cargo PGRX in it. So what this is going to do, it's going to create for you 5 PostgreSQL instances in your home directory. Okay, so you're going to have 5 different PostgreSQL instances in your home directory for testing. So it's going to eat a lot of space on your home folder, but yeah, you're going to be able to launch at any time a PostgreSQL instance. So let's now create a project called world. and with cargo PGRX new world. And let's look inside what's this new project. In this new project, you have a libRC file with this function that you may recognize as Rust code. I guess you understand what this does. But the new thing here is that you have this this attribute at the first line which says PG extern. All right? So this macro attribute will just say that this function will be callable. You can call this inside Postgres. That's all. That's all you need to do to expose it. I just drop the previous version of the extension and create the new one. And here we go. I can select this function with my parameter. All right. Let's go a little bit deeper now. Oh yeah, sorry. If you wanted to do this in C, this is approximately, maybe you can do it in a few less lines, but basically this is how you would do it in C. So, yeah, no comment. Any Canadians in the room? Good, good. So let's have a better example. So the Canadian Social Insurance number, which I will call SIN, is composed of 9 digits, sorry. So the 8 first are the real digits, and you have the last one is just a control bit, a checksum. And this control bit is computed with the learn formula, which says that if you have a 0, 4, 6, etc., the control digit is 6. How does that work? I don't know. I don't care. But unfortunately, there is a crate that has implemented this algorithm. So I'm going to use it. All right? And I'm going to expose a function that just computes this checksum. So I'm just going to import the checksum function because I don't need anything else. And again, I'm going to take in input a text and output just the character of the checksum. Let's go back. We rebuild the extension. Let's go again. And here we go. We have the checksum implementation right away. And of course, if I provide something that is a text but is not a number, it will fail. And again, it will fail without crashing the whole server. So it's good. But this is manual testing. But now I would like to test this. I would like to add a unit test around this. So again, I'm going to use very classic tooling from Rust with this test functions. And again, you have the PG test attribute for this function, which is just going to say, okay, these functions, you need a PostgreSQL instance to test it. So you see, again, I'm just going to check that the checksum of 1 is 8. And let's go. I'm simply going to launch cargo PGRX test. All right? And so, but cargo PGRX will launch a PostgreSQL instance and call all my tests against this instance. And if I want to check on another versions, I can just say output functions. So this has the 2 first lines here are crucial. And the input and output functions are just traits, all right? So I'm going to declare a trait, an input trait that will receive a C string, and I will have an output trait that will display, again, the text representation of my type. So the input is quite simple. I'm just going to receive the text. I'm going to remove all the spaces, and I'm going to validate that this is a correct Lune number, all right? And the other way around, I'm going to take a valid number and I'm going to output it. I'm just going to split the number into 3 parts so it's easier to learn, to watch. Again, let's try this. So, as you see there, I'm going to cast, so I'm going to take a text and transform it into my new scene type. So the first one will work, as you see. I'm going to push some text, and the output is well-formed. And the other way around, if I'm pushing an invalid number, I'm going to get an error. Okay, so let's now use this as an inside a table. So I'm creating a table for all the Canadians, and it won't work. It won't work because I didn't specify my operator classes for this type, because as this is a primary key, I need to have some operators to sort this data. So let's go back to the Rust code, and I'm going to add more and more and more operators, so more attributes to derive all these ordering operators, equality operators, etc., etc. Logical replication system. You can basically build your own index method. You can also build your own table access method. This is you can almost do anything with this. So here's my feedback now from rewriting the extension in C to Rust. So the PostgreSQL Anonymizer extension is just a data masking extension, so you can put rules upon some columns and say, okay, this column should be masked like this, or this column should be blurred or anything. I'm not going to talk about it right now because I'm going to talk about it tomorrow in the PostgreSQL dev room. If you want to learn more about data privacy, see you tomorrow. But yeah, on the technical side, it was about 1,000 lines of code, of C code. So not that big of a project, but still, again, some fairly used curse base. And I took me like a few weeks to rewrite everything without prior knowledge of Rust. So it was kind of difficult at the beginning, but you get a sense of déjà vu, which means, as a PostgreSQL DBA, you're already kind of accustomed to the fact that, it's hard at the beginning to make things, when you start to make things properly. Rust compiler is kind of dull and rough for beginners. I think most people know that. But once you climb the ladder, once you reach a certain level, you get rewarded because you got good habits about it. And it's pretty much like Postgres, actually. So, yeah. And so immediate gains by switching to Rust was the comfort of development, because I don't spend a lot of time on this project. It's kind of a side project. So when I go back to the code, I need to both in a few lines to blur the imaging inside the database. This is something that would have been very, very difficult to do in C, of course, and even more difficult in PL code. And so I get stability, so no more seg faults, and basically I'm really, I'm sleeping better now that I know that this extension won't crash in the front of end users. So there's gains, but there's also some cultural differences. So the first one is that in Rust, nothing is null. Everything is defined and well-defined. Whereas in Postgres, by default, if you don't set a value into the column, the column is going to be null. So you need to switch a little bit your mindset about that. Also, everything is not about the Postgres internal functions. Everything is not ready available right now. So you still need to do some digging and some workaround to get what you want. And also, it's kind of complicated at first because you have two memory contexts. You have Postgres memory context and the extension memory context, and if you want to pass object from one to another, it's not that simple. And it's not magic, it won't work. It's not entirely safe, so you still need to do some unsafe section in your code. The building process is really, really slow, so that's a major problem for us. Because it took, basically in C, the extension took like 1 minute to compile in CI, and currently in CI it will take like 20 minutes to compile. So yeah, and you need to compile it upon the 5 current Postgres versions, so that's 5 multiplied by 20. You also have no support of Windows at the moment, so I don't know if that's a problem, but yeah, maybe for some problem for some people. And for advanced feature, you still need to read and understand the Postgres key. And so, yeah, just come on and try it by yourself. Actually, it's really, really easy to bring back your code close to the data. Always a good idea, if you ask me. As we said, one of the easiest way to start is to create data types that are relevant for your use case, and use them for indexation, for control, for data quality. And just think of Postgres as a platform and not just a database. And yes, overall, if you want to have a first step in the Postgres community, actually REST extensions are a great entry point to start. And that's it for me. So if you want to learn more about the PGRX framework, the website is there. I also did a 4-hour tutorial with many more examples, which is available. And if you want to try the PostgreSQL Anonymizer extension, it's also on GitLab. Thanks a lot.
Any questions? Yes.
Thank you. How do you distribute those extensions?
I didn't understand, sorry.
How do you distribute the extensions?
It's a really good question. So you have in Cargo PGRX, you have a release option that will build up all the folder for building packages, right? Again, I wouldn't advise to people who won't use Cargo to install this in production, of course. So you need to build RPM and Debian packages. The problem now is that the official Postgres repository will not build this RPM for you. So they won't build a Rust project and Go project, actually, or two. So right now the extension is not available on the PGDG, on the official PostgreSQL repositories. This is the situation right now. This may change, but like I said, with the building time the CPU time it takes to build all these versions, it's not a simple issue for them. So, yeah.
Currently, Postgres has row-level security, and I was wondering, with this extension mechanism, can you make that even finer and build field-level security by implementing a Rust extension?
Sorry, I didn't understand again. Yeah.
Currently, Postgres has row-level security implemented in it. Not perfect, but it's there. I was wondering if you can write a Rust extension to make that even finer and do it at field level. Would that be feasible?
My extension against the data, like having fixtures already loaded in the database, how can I have it, for example?
So
For example, I want to test my extension against the full table, like with thousands of lines.
yes,
thousands of
you
records.
just create this